Hi, my name is Jingzhu Yu. I'm currently a PhD student in the Department of Civil and Environmental Engineering at Vanderbilt University. My research focuses on the analysis of risk and resilience using Bayesian statistical methods. Today, I'm going to talk about modeling community resilience under sparse data using a method called Hierarchical Bayesian Kernel method. Every year, extreme natural events like hurricanes cause tremendous damages in America, such as disruptions to business, houses, and infrastructures. In the summer, Hurricane Harvey caused billions of dollars damages in Texas.
Damage from Hurricane Harvey will likely reach between 150 billion to 180 billion. Harvey, the most powerful hurricane to hit Texas in 50 years, has killed an estimated 47 people and displaced more than 1 million. In the face of these devastating disasters, some people might ask, what can engineers do to help? Well, my answer is community resilience. Although we are unable to prevent disasters from happening, we can help our communities to get better prepared for the disasters in advance and accelerate the recovery process after the disasters. And community resilience, which is generally referred to as the capacity to bounce back after disruptions, is such a concept that helps us to measure the recoverability of communities. Resilient communities can significantly impact disaster relief because a resilient community is able to adapt to changes in the physical, social, and economic environment. In recent years, researchers have been trying to quantify resilience to improve the measurement of recoverability of communities, and various metrics have been developed for different types of hazards. But the challenge in quantifying and modeling those metrics is lack of data. The lack of data results in difficulties in measuring and predicting resilience metrics within an acceptable level of accuracy. In order to handle this problem, we developed this hierarchical Bayesian kernel model. This model is an integration of the hierarchical Bayesian model and the kernel function. The hierarchical Bayesian model improves the accuracy of primary estimation by adding an extra level of Bayesian updating, while the hierarchical structure allows us to borrow data from other subsystems in cases where we don't have enough information. And the kernel function acts as a measurement of similarities between new data and existing data, and then it is incorporated through the likelihood function. We applied this method to analyze one aspect of the resilience of Shelby County, which is related to the number of people without power after a disaster. Shelby County, which includes Memphis, the largest city in Tennessee, is subjected to hazards like earthquakes, flooding, and storms. We collect data from the local utility company, Memphis Light, Gas, and Water. Using their news releases and Twitter updates, we're able to determine the number of customers without power as a function of time after each storm. The data span over 10 years and include about 20 disruptive events. Here we present the data for the 5 most damaging ones. The specific model for the power outage data is Poisson hierarchical Bayesian kernel model. Poisson distribution is used to model the data. The prior is modeled using the gamma distribution, which is conjugate to Poisson distribution. After formulating the model, we use cross-validation to evaluate the model performance. The results here are from 2 storms. Looking at the comparison of predicted and observed values, we notice that the model has very good prediction power. And the nice feature of the model is the ability to quickly update the estimation as we learn more information during and after a disaster. The hierarchical Bayesian kernel method is available for modeling resilience when relying on very limited data. This data can come from different sources, such as utility companies and social media. And our model can help integrate diverse information and provide accurate predictions. In the future, we will incorporate demographic data to build a more comprehensive and accurate measure of community resilience. This can assist responders and planners to better prepare for future events. Thank you for watching.